In the 20th century, humanity reached for the stars. In the 21st, we may be reaching inward, to the very fabric of the human brain. At the intersection of two of the most radical frontiers of our time, space exploration and neural engineering, lies a question once reserved for science fiction. What happens when the human brain goes to space, not just biologically, but digitally? Elon Musk's company, Neuralink, has already begun testing brain-computer interfaces designed to merge our minds with machines. While the technology is still in its early stages, its long-term implications extend far beyond medicine or mobility. Some futurists, and even Musk himself, have hinted at a grander vision. Neural interfaces in space, where astronauts might one day control spacecraft with their thoughts, access information telepathically, or even communicate brain-to-brain across vast distances. Could Neuralink help humans adapt to space travel? Could it one day enable interplanetary mental communication, or even digital immortality in orbit? Let's explore how this rapidly evolving technology could reshape humanity's place in the stars, and what it might mean for the future of space itself. Neuralink is a neurotechnology company founded in 2016 with an ambitious goal to create a direct interface between the human brain and external computers. The company's signature device, a brain-computer interface, BCI, involves ultra-thin, flexible threads implanted into specific regions of the brain. These threads can detect neural activity, the electrical signals that form our thoughts, movements, and memories, and translate them into digital commands. In its early tests, Neuralink has already enabled paralyzed individuals to move a cursor, type with their thoughts, and interact with basic digital systems, all through direct brain signals. But the long-term vision extends much further. Imagine a future where the brain is seamlessly connected to cloud storage, AI assistants, robotic limbs, or even remote systems thousands of kilometers away. Neuralink proposes a world where humans evolve alongside their machines, not just using technology, but becoming part of it. And when it comes to space, that kind of symbiosis could be more than futuristic, it could be necessary. Space is the most extreme environment humans have ever ventured into. It alters everything, from our muscles and bones to our blood pressure and vision. And yet, one of the most vulnerable systems of all is the brain. Extended exposure to microgravity can cause fluid buildup in the skull, cognitive slowdowns, and increased pressure on the optic nerves. Sleep cycles are disrupted. Stress levels soar, decision-making can degrade, and all of these factors become more pronounced the farther we travel from Earth. Now imagine we're no longer talking about months in orbit, but years on a Mars mission or lifetimes in deep space. Could a brain-computer interface help? Neuralink might one day act as a cognitive co-pilot, monitoring neural function, enhancing memory recall, assisting in complex problem-solving, or even stimulating specific brain regions to combat mood disorders, memory loss, or mental fatigue. In an environment where astronauts must make life-or-death decisions in isolation, the ability to augment cognitive capacity may prove as critical as oxygen or water. In science fiction, space travelers often operate ships with a flick of the mind. Neuralink is inching toward making that a reality. If a brain-computer interface can decode motor intentions, the signals your brain sends when you want to move your hand, for example, then in theory, it could be trained to recognize complex commands, such as navigating a spacecraft, manipulating robotic systems, or adjusting life support parameters, all without touching a console. This would reduce the need for manual controls in high-stress or zero-gravity environments. Astronauts could interact with systems even when injured or immobilized. Missions could become more autonomous, efficient, and adaptive. In the long run, an advanced neural interface might even allow for multimodal control, combining traditional movement with direct neural input, enabling smoother interaction with AI, faster decision loops, and reduced human error in high-risk environments. As spacecraft become more intelligent, perhaps the way we command them must evolve as well, through thought itself. One of the most persistent challenges in space travel is communication lag. Radio signals traveling to Mars can take up to 22 minutes each way. That delay renders real-time conversation and urgent commands nearly impossible. But what if astronauts could communicate brain-to-brain? Not with words or typed messages, but through neural impulses, emotions, intentions, and thoughts transmitted directly from one mind to another. While this might sound far-fetched, early research has already shown that basic information can be transmitted between brains using BCI technology, such as simple yes/no signals or directional instructions. If Neuralink and similar companies can scale this up, we may one day see the emergence of neural messaging networks, capable of compressing and transmitting mental data. This kind of communication wouldn't just be faster, it could be more nuanced. Subtle cues, emotional states, and complex thoughts might be exchanged with unprecedented clarity, reducing misunderstandings in tense mission environments and allowing for richer collaboration between crews. And as humans begin to settle distant worlds, such a system could bridge the emotional isolation of deep space, keeping minds connected across light years. As space missions become more complex, the relationship between humans and machines will become increasingly critical. Neuralink could act as a neural gateway to artificial intelligence, enabling a new kind of synergy between biology and technology. An astronaut linked to an onboard AI might experience the mission interface as a shared consciousness, with the AI predicting needs, managing resources, and analyzing hazards in real time, all while adapting to the astronaut's mental and emotional state. This raises the possibility of a neural co-pilot, not simply a tool, but a companion, an intelligence that lives partially inside the human mind and partially within the ship itself. In the longer term, brain-AI fusion could unlock problem-solving at a scale currently unimaginable, allowing astronauts to process massive amounts of data, analyze complex simulations, or troubleshoot hardware with near-instant insight. The result? Faster, safer, smarter space missions, piloted by a hybrid of human intuition and machine precision. Beyond mission support, Neuralink hints at a much more philosophical possibility, the idea of mind uploading or neural backup. If our memories, thoughts, and even personalities could be recorded digitally, it raises unsettling but fascinating questions. Could astronauts preserve their consciousness before a dangerous mission? Could a brain backup be transmitted across space to operate in robotic bodies or virtual avatars? Could we, one day, exist not just in physical form, but as digital minds inhabiting ships, satellites, or Martian colonies? This concept, sometimes called substrate-independent minds, could allow humans to travel space in a new way, not as fragile biological organisms, but as information. Consciousness could spread faster than light, not physically, but via data, and be reinstalled wherever suitable machines exist. Of course, the ethical and philosophical implications are enormous. What does it mean to be you if your mind exists in multiple places at once? Is identity something we can truly upload? Yet in a future where planets are months or years apart, digital minds may be the only way to conquer distance and time. As we push deeper into space, we're beginning to realize that the next leap forward may not be just technological, it may be neurological. With Neuralink and similar innovations, we are not only enhancing human capability, we are redefining what it means to be human. The merger of brain and machine may enable us to explore the cosmos in ways biology alone never could. From controlling spacecraft with thought, to bridging minds across light years, to creating a form of consciousness that can survive the void. The possibilities are breathtaking and unsettling and exhilarating all at once. But this is no longer the realm of science fiction. The technology is real. The tests are underway, and the implications are cosmic. As the rocket engines roar and the capsules rise, humanity is not just bringing its bodies to space, it's bringing its minds. And perhaps one day, long after we've left the Earth behind, it will be our thoughts, our memories, our very consciousness, orbiting among the stars.